The very first question that comes into mind, that when we are having the electric field, then what's the need of defining another physical quantity? What's the need of defining electric potential when we are having the electric field? So here is the situation that, for example, if we are having two positive charges, or let me consider first that this is a region, and in this region, let's say this is an arbitrary region, and in this region we are having no charge, that is, the source charge is equal to 0, then this will tell us, from Coulomb's law we came to know about this thing, that electric field will be 0 in that region as the source charges are equal to 0. Now if, for example, we are having two positive charges, like we are having a positive charge here and a positive charge here, and both are of the same magnitude, Q and Q, then what is the electric field at the center? Now the field at the center is E equal to 0. The electric field at the center is equal to 0. Now let's look here and here. These are two different scenarios. Like, for example, we are having this region here, any arbitrary region in which we are having this situation. Now look here. Here the electric field is 0 by magnitude. Like, the magnitude is such that the electric field is equal to 0. And here the electric field is 0 by magnitude, but not due to the source charges. Here the electric field is 0 because there are no source charges. Here are the source charges, but the electric field is 0. Now these two things are 0. This we say that this is due to the source and this is due to the geometry. So the two equal to 0, how we will tell the mathematics that this equal to 0 is different from this equal to 0. And there comes the need that this one is coming out to be 0 due to the reason that the two electric fields are cancelling each other due to their vectorial nature. So the concept of electric potential comes here, that we need something that depends on, not depend on the vector form, or is not supposed to be vector in nature, but to be a scalar. And here V will not be equal to 0, but here V is equal to 0 as well. So the vectorial nature was giving us a problem there, and it was giving us 0. Then we got rid of this thing by introducing its scalar counterpart, and that's why we can easily differentiate that here it's a different scenario and over there it's a different scenario. And there is a need of defining electric potential.